Have you ever looked up at a giant skyscraper, a brand new bridge, or even just the house being built down the street and wondered, how does that actually happen? How does a drawing on a piece of paper become this massive, real-world thing? Well, it's definitely not magic. It's a really fascinating mix of management, money, and engineering. So let's pull back the curtain and see how it all gets done.
See, on one hand, you've got the idea, right? The architectural blueprint, it's lines on a page. And on the other hand, you have the reality, a towering, finished skyscraper that you can actually walk into. The gap between those two things is just massive. It's filled with thousands of decisions, tons of people, and a whole lot of coordination.
So what's the secret sauce that bridges that enormous gap? Well, it's a whole field called construction management. And as you can see here, it's not just one thing. It's the entire system, the whole shebang of planning, scheduling, and controlling a project. Think of it as the operating system, the how, that turns a simple blueprint into an actual building.
Okay, so to really get how this works, we need a roadmap. And in construction, that map is called the project lifecycle. This is the journey that every single project takes, from the very first glimmer of an idea all the way to its final days, years and years down the line.
And here's what that journey looks like. It all starts with a need, right? Maybe a city needs more housing. From there, you get into planning and feasibility. You got to ask, can we even do this, and does it make financial sense? If you get a green light, then you move into design. Then the actual hard hats on the ground construction. After it's built, there's a startup phase so people can move in, and then, way down the road, eventual disposal. It really is a cradle-to-grave kind of process.
All right, so we've got our map, but who are the people actually making this journey happen? Well, every single project needs its own A-team, a core group of key players who are essential to getting anything built.
And it all begins with the owner. This is the person or company with the vision and, let's be honest, the wallet. They provide the funding, they handle the permits, and at the end of the day, they are the ultimate authority. Nothing, and I mean nothing, happens without their say-so.
Next up, you have the architect. They're basically the owner's chief agent. They take that big vision and translate it into detailed plans that people can actually build from. And, this is super important, they also stick around to supervise the work, making sure the final building is exactly what was designed.
Then, you bring in the engineer. This is where the science really kicks in. These are the folks who make sure the pretty design, well, doesn't fall down. They figure out the structural integrity, the electrical systems, the plumbing, all the technical stuff that makes a building safe and functional.
So who wrangles all these different experts and workers? That would be the general contractor. And I love this analogy. They really are like the project's conductor. They might not play every instrument themselves, but they're the one making sure all the different parts, the electricians, the plumbers, the painters, are all playing in harmony and on schedule.
Now, these roles and this process apply pretty much everywhere. But here's the thing. Not all construction is created equal. There are really four main flavors of construction, and each one has its own unique set of challenges.
First up, we've got residential housing. This is the stuff you and I see every day, right? Single-family homes, apartment buildings, whole subdivisions. These projects tend to be a bit smaller, often with repetitive designs, and contractors will hire a whole army of subcontractors for specialized jobs like roofing or drywall.
Then you take a big step up in complexity with institutional and commercial buildings. We're talking about things like schools, hospitals, shopping malls. The designs are way more intricate. The safety requirements are incredibly strict, and you need all kinds of specialty engineers. Just think about what it takes to design the ventilation system for a major hospital. It's a whole different ballgame.
And then you enter the big leagues, specialized industrial construction. This is stuff like oil refineries and power plants. These projects are mind-bogglingly complex. They cost an absolute fortune, and because time is literally money, they often use what's called a design-build method. That's where one company handles everything from design to construction just to hit the fast-forward button.
And finally, we have infrastructure and heavy construction. These are the massive projects that form the backbone of our society. Highways, bridges, dams, you name it. And the key thing to remember here, these are almost always public works projects, meaning they're funded by the government, with our tax money.
Okay, so that's how everything is supposed to work in a perfect world. But let's be real, construction is messy, and it rarely happens in a perfect world. The schedules are incredibly tight, and when things start to slip, the costs can get out of control fast.
This leads to a really, really important question. What actually happens when a project starts falling behind? It's not just a matter of being a little late. There are some very real and very painful financial consequences.
And that consequence has this very formal-sounding name, liquidated damages. But don't let the legal jargon fool you. This is basically a massive penalty fee. It's written right into the contract, and it means the contractor has to pay up for every single day the project is late.
So, just how massive are we talking? Well, for a typical 100 million peso project, that penalty is usually set at 0.1% of the project cost. Do the math, and that comes out to a staggering 100,000 pesos per day. Think about that. A delay of just 10 days costs the contractor 1 million pesos. The pressure to finish on time is absolutely immense.
So when you boil this entire complex process down, you find that every successful construction project really stands on 3 fundamental pillars. And for a building to go from blueprint to reality, these 3 systems have to work together in perfect harmony.
And here they are. First, you have the technical system. That's the smart design and the solid engineering. Then you have the management system. That's all the scheduling and coordination that the conductor or the general contractor handles. And finally, you have the legal system, the contracts that everyone signs, and the penalties, like liquidated damages, that keep everyone honest. If any one of those pillars starts to crumble, the entire project is in serious trouble.
So I'll just leave you with this question. The next time you walk past a construction site and you see a crane swinging against the sky, what are you going to see? I bet it won't just be steel and concrete anymore. You'll see those invisible systems hard at work, the intricate dance of design, management, and law that makes it all possible.